Hi everyone, welcome back to LeetJourney. Today we'll design a unique ID generator that runs in a distributed system. This is part of the system design interview series I have started. Many tech companies ask system design questions as part of the recruitment process, so it's crucial to be able to ace these kind of interviews. Before we jump into the details, let's understand why a distributed unique ID generator is crucial in large-scale systems. In a distributed environment, generating unique IDs becomes challenging due to the lack of central authority. We'll be designing a solution that ensures uniqueness, scalability, and fault tolerance. Imagine you are building a system where users can generate unique IDs for various entities like transactions, user accounts, or messages. How do you design a system that ensures these IDs are unique, even in a distributed environment? Let's now jump into the actual system design exercise of the unique ID generator. When starting the design of your system, you will want to identify functional and non-functional requirements by asking questions to the interviewer. Let's establish some requirements for our unique ID generator. IDs must be unique. IDs must fit into a 64-bit variable. IDs must be numerical. IDs should increase by time. A unique ID created at 10 p.m. should be bigger than the one created at 11 a.m. The system should handle a large number of requests and scale horizontally. And finally, the system should continue working even if some of the components fail. There are various ways in which we can generate a unique ID, such as the following. Universally unique identifier. UUIDs are designed to be globally unique across space and time. They are usually generated using a combination of timestamp, node identifier, and random bits. Universally unique identifiers are an easy way to obtain unique IDs, but they are 128 bits, which violates our requirement for the ID to be 64 bits instead. The next way to generate a unique ID is to use the database auto-incrementing IDs. For systems with a central database, auto-incrementing integer IDs are a straightforward choice. Each time a new record is added, the database increments the ID automatically. This works great if we have a single data center with little traffic, which is not the case for us. Then we have the Snowflake Algorithm. Developed by Twitter, the Snowflake Algorithm uses a combination of timestamp, machine ID, and a sequence number. It provides a good balance between uniqueness, ordering, and simplicity. This is the best choice for our use case. Let's talk a bit more in detail about how Snowflake works and how the IDs are generated. The Twitter Snowflake algorithm is a unique ID generator designed for distributed systems to generate unique IDs with the following characteristics. Timestamp ordering. IDs are roughly ordered by the time they were generated. Uniqueness. IDs are unique even in a distributed environment. Distributed system support. It is designed to work in a distributed system with multiple nodes. Here is a simple explanation of the Snowflake algorithm. The initial bit is reserved for future use. The next 41 bits are for the timestamp component. The IDs begin with a timestamp measured in milliseconds. It uses 41 bits to represent the time elapsed since a custom epoch. This provides a time span of about 69 years. The next 10 bits are for the node identifier. Each machine in the system should have a unique identifier. This can be achieved through a configuration file, environment variable, or a dynamic registration service. With 10 bits, it supports up to 1024 unique machines in the system. And in the end, we have 12 bits reserved for the sequence number. In case multiple IDs are generated within the same millisecond from the same machine, a sequence number is included. This 12-bit sequence number allows for generating up to 4096 unique IDs within the same millisecond and machine. By combining these three components, Snowflake ensures that the generated IDs are unique, ordered by timestamp, and suitable for use in distributed systems. It's worth noting that Snowflake requires synchronization of the system time across all machines to avoid issues related to clock drift. Additionally, it may not be suitable for scenarios where a single node failure poses a significant risk, as it heavily relies on a unique machine ID. At the end, the interviewer could ask you some follow-up questions which you will need to go over briefly, explaining your approach. Here are some example questions. In a distributed environment, clock synchronization can be challenging. How does your design handle clock skew among different machines? What happens if one of the machines generating IDs goes down, and how can the system recover? How do you guarantee the uniqueness of machine IDs across the distributed system? And there you have it, a high-level overview of designing a distributed unique ID generator. Mastering this concept is not only essential for system design interviews, but also for real-world scenarios where scalability and fault tolerance are critical. This was a short video. If you have any feedback or further requests, leave them in the comment box below. I hope you enjoyed the video and found it somewhat useful to reach your goal. Please don't forget to like and subscribe, as it allows me to keep creating more and better content for you, all completely free of charge. See you on the next video.